Okay, so we will talk about today hierarchical clustering. Clustering, okay. So you can understand that meaning of hierarchy, right? It is based
Yes.
on the levels. Okay.
Yes.
So level by level, we will be trying to create a cluster. This is the hierarchical clustering. In that, there are two methods are there, okay. One is called as agglomerative. Okay, spelling may be wrong. Okay. And another thing is divisive. Okay, divisive. So agglomerative clustering, okay, and divisive are the two ways by which we create a hierarchical clustering. Okay, so hierarchical means level wise. Okay, we will try to cluster it. Okay, we are totally aware about what is the meaning of cluster. Cluster is the meaning of group. The meaning of cluster is group. Okay, so agglomerative has a principle. Okay, so let's come to the agglomerative part. Okay, divisive actually it is not used much. Okay, and slightly it has a problem of scale. Okay, so it is not used that much. Okay, even hierarchical is not used much. Okay, but in hierarchical, agglomerative is the um, the better way to use it.
Okay.
So agglomerative, what it says that whatever your data points are there, okay, all data points are treated as a cluster. Suppose this is a data point. Okay, these are the data point. Okay, all data points are considered to be a cluster. Okay, cluster, that the group. Now what happens from each point, like this is a P1 point, this is a P2 point, like that, this is a Pn point. Okay, from P1, okay, all the distance are measured. Okay, like distance of from P1 to P2, distance of P2 to P3, like that, all the distance are measured. Okay, now whichever has the lowest distance. Okay, so what you will do, you will create one matrix is created with the P1, P2, like Pn, and here also P1, P2, Pn. Okay, a matrix. You understand the matrix, right?
Yes. Yeah.
Okay, so here P1 to P1 distance. Okay, so P1 to Pn distance will be 0, correct?
Yes.
Now P1 to P2 some distance will be there. Suppose that it has a distance of suppose 1.2. Okay, P1 to P3 some distance will be there. Suppose it has a 1.5 distance. Okay, P4 something is there 3, like that, like P2 to P1. Okay, P1 to P2 and P2 to P1, it will be same, right? So 1.2. Okay, so it has a repetitive. Actually, if you take this side, is a replica of this side. Okay, because it will be
Okay.
matching. You are getting the point, right? P2 to P1 or P1 to P2, it is same, right? Like here P3 is there. Okay, some distance will be there. So what happens, we measure the distance from each point to all other points. Okay, and we measure that which has the lowest distance. Okay, suppose in this case, suppose that I am taking 3 and it has suppose 5. So if you check it, the lowest distance is P1 to P2, right? 1.2. Other has a higher distance, correct? If you see
Correct.
1.2, this, correct? So what we will do that, we will merge it. Okay, at 1.2 distance, this two cluster has merged. Okay, I made a one cluster. Okay, now from 2 points I am making a one cluster, one group. Okay, likewise we will check what is the other points, okay, which are closer to that. Okay, which are closer to that. So suppose this is closer to that. Okay, in the second iteration, suppose it has merged that 1.5. Okay, this is P3. No, because P1 is already taken, so this won't be there. Like suppose matrix is there. In the matrix,
Okay.
whole matrix is there. Some points are there. Okay, some points are there. So in that, we will be checking in the matrix. Okay, because P1 is already merged with some another point P2. So P1 and P2 is not right now available. Okay, not available from that perspective. Now we will check it. Okay, we will check it that individual points are not right now available. Okay, so we will check for the other points whether that have the lower distance or not. Suppose P4 and P5 are closer distance. Okay, they are the distance between them is suppose 1.5. Okay, 1.5 is there. Okay, so it is merged at 1.5. Like that, we will check for all the points. Okay, this is the step number one. Okay, so suppose that it is merged. This was merged at certain point. Okay, now rest are not merged. Suppose. Okay, now the point is that suppose these points, the distance between these are not very. It is very high. Suppose. Okay, high. Now these 2 points has been created as a cluster. Okay. Now, as you know that it is a hierarchical process, it means hierarchy will be created. Now, this cluster should also try to merge cluster or the points which are nearer to this. Okay, nearer to this. Now, the question is that if you want to measure a distance from this cluster,
Okay.
how you will measure it? You have 2 points, right? This point and this point. How you will measure the distance? If you have to measure the distance from this cluster to suppose these points or to any other cluster, how we will be measuring? It has a
Uh,
problem because right now I have a 2 points, right?
Correct.
Because if it was a single point, there wasn't a problem because that single point has some your whatever the coordinate values were there. Okay, if we put into the some dimensions, okay, that coordinate dimensions, it had some points. Okay, value was there, and that was the that only one value was there. Right now, it is an ambiguous situation. Okay, what to do?
Mhm.
So here we have to take some decision or to find out by how many ways I can do the calculations. Okay, so to identify that how to measure the distance from this particular cluster. Okay, there are a different method is there. Okay, that is called as a linking method.
Okay.
Linking methods. Okay, linking methods. Now how to link it? Okay, link it here. So right now just assume it. Okay, let's assume it. We will come to the linking method. There are different ways are there. Okay, right now assume that the best way is that get to the center of this. Okay,
Okay.
whatever the two values are there, get to the center of this, the centroid of this. Okay, so the value of this, actual value of this, plus the actual value of this, okay, divided by 2, the average of it, that the centroid, the center value. Got it? We can
Yes.
do the, we can do the center value, something I have taken. Now, this center value now can be considered as a point, correct?
Hmm. Correct.
Similarly to this, okay, now again I will be measuring the distance, suppose from this point only to all the points. Okay, so now I am treating this cluster, this is cluster suppose 2, cluster 3. Okay, and 2 at suppose second iteration, 2 at second iteration. I am giving the name because every time we can use. This is a cluster 4 at second iteration, cluster 5 at second iteration, cluster 6 at second iteration. Now the point is, I will again measure the distance. Again, I will create the matrix. Okay, I will again create a matrix. Same way. Okay, so consider this as a suppose C1 cluster. Okay, or the point, new point, whatever we want to denote it. Okay, and again I will measure the distance. Okay, whichever has the shorter distance, I will merge it. Okay, so now if you see that this may have the shorter distance, I merged it. Okay, and
Okay.
whatever the distance between that at that place it has been merged. Okay, Like this,
Yeah.
suppose this has merged at this place and this was merged at this distance. Okay. Now,
Okay.
okay, now I am again doing the same method. Right now, if you see that it was this particular point was merged with this as a this is the effective point. Okay, cluster effective point. Now again from
Okay.
these places, I will again measure the distance. Okay, now if I measure the distance, suppose it is a closer one, I merged it. Okay,
Yeah.
now if I measure the distance between this and this, at this it has been merged. So now
Okay.
from a single point cluster, I make a one big cluster. You are seeing it, right? Right?
Yeah. Yeah. Yeah.
We merged it. Okay, we merged it, and to the all the points we have merged it. Now, this is called the hierarchical. You can see that it has a hierarchy. Okay, this has the levels,
Okay.
level at which it is just doing it. Okay, doing it. So this is the hierarchical clustering for us. Okay. Now I told you there is a linking methods. We will come to the linking methods. Okay, linking method. Right now, any question?
No. So how we use it? Because we got a hierarchical cluster now.
Mhm.
So, how we use this clusters?
Okay,
I
now
mean, at the end.
we will come to the point. Okay, so this is how it
Okay.
is cluster is created. So one thing is that how clustering is done, we are aware. Okay, this is how it
Okay.
is done. Okay, so we will come to the second point. Okay, now, so I know that how clusters are created. Okay, so like these were the points were there. Suppose these were the points like this and like this. The hierarchy was created. Okay, suppose that. Okay, this is the hierarchy, suppose now. Okay, now it is created. This is a point P1, this is a P2, this is a P3, P4, P5, P6. Okay, now
Okay.
this is the distance. Okay, distance at which it has happened. Suppose it has happened at 1.2. This was merged at suppose 1.3, like that. Whatever the distance are there, it is there. Okay, it is merged.
Okay.
Okay, now, this is the hierarchy. Now, this particular diagram, the tree structure is called as a dendrogram. Okay,
Okay.
dendrogram.
Okay.
Okay, dendrogram. This is picture. Now, if you see that when we were trying to create a k-means, okay, k-means uh, we had to tell the system that how many cluster we want, correct, at the
Mm.
beginning.
Mm.
In this
Yeah.
process, we don't say that how many cluster we want.
Okay.
I will apply the hierarchical clustering method in that there are some of the points are there which we will coming to. We will create the hierarchical clustering. Okay, suppose that normally I created it. Okay, we have taken the suppose Euclidean distance and created this. Okay, this is
Okay.
done. Now after creating this cluster, I will view the dendrogram. Now if you view the dendrogram, what is the benefit you are getting it from the k-means perspective? If you see that now if you see that you are able to see that how your points are data are combining, right? And right now, not based on your gut feeling or not based on your random choice, you are selecting the cluster. Right now you can consciously, based on requirement, you can think about the how many cluster you want. Suppose you see that if I cut at this place, suppose I want to cut from this place. Okay, suppose you think that, so you know that 1 2 3 4 this is one cluster, this is two cluster, three and four cluster you are getting it. If at this
Yes.
distance you are doing it, cutting it,
Two
you are getting
clusters.
it one cluster, two cluster, and three cluster. If you are
Okay.
cutting at this point, you are seeing that you are getting the two cluster. One is a single point and rest are the other points. Okay. So it is
Okay.
giving you the idea that this is the distribution of the data, this is how we are able to merge it. What way you want to have the cluster? You can also cut it here also. You can take it from
Yes.
cluster here. So 1, 2, 3, 4, 5. 5 cluster will be there. So it gives you the visual representation and it gives you the idea based on this data how much natural formation of the clustering is happening. Okay.
Mm.
And you can take the decision at the runtime. After doing certain thing, you are taking the decision that how much cluster I want to have. Okay.
Okay.
Otherwise, you had to decide at the beginning only that how many cluster you want to have. So this is the one advantage you are getting. Correct. Because you are
Correct.
making the decision based after seeing something. And I started recording, right?
Yes, it's showing recording.
Okay. So this is the advantage I am getting. Okay. So this is the part of the your hierarchical clustering. So this is the another technique. Okay. As I told you, it is a hierarchical part, and this
Mm.
proper way is that called as a agglomerate. Here you have the power of dendrogram. It is a tree-like structure. How, at what distance, different points or different clusters has combined. Okay, that is the power you get it from the hierarchical clustering. Okay, and you can make the decisions there. Now, uh, this is the one part. Okay, done. Now we will come to the linking method, because in the linking method we decided that we will take the centroid, center of the different points as a you know as a point from where I will be measuring the distance or the similarities. Okay, I will be measuring the distance or the similarities.
Mm.
We have already covered the distance and the similarities. Okay, and we will have the link, the videos. We have already that videos for that. Okay, we will put it into our description also to see that what is the meaning of similarity. What are the distances are there? Like we have seen the distance, Euclidean distance, right? Manhattan, Chebyshev.
Yes.
Okay, Chebyshev. From the similarity perspective, there is a your Jacquard distance is there, cosine similarity is there. Okay, there is a Gover distance is there. There, I talked about the Mahalanobis distance. So there are many multiple type of distances are there. Okay, which we will again see it. Okay, again see it that how we can do it. But this is how it is done. Now the linking method, because linking method may be the important way to deal with. Okay, so this is done. Let's go to your new page. Now linkage method. Okay, something called linkage.
Okay.
Linkage. So there is a linkage called single linkage. Okay, that is also called as a minimum. Okay, one.
Mm.
There is something called complete. That is also called as a max. Then there is called as an average linkage. So average is average. Fourth is called centroid. There is fifth called wards. Okay, wards. Okay, there are other also could be. Okay, but let's see that this only. By that we will be able to understand it. Okay. So single linkage means that suppose this is a cluster, two cluster. I told you that, right? It is ambiguous that how I will be measuring it. Okay. Suppose there is a point here and point here. So what you will do that, suppose this is a point P1, this is a P2, this is a P3, and this is a P4. So what you do, you measure the distance, okay, from all the points, like from P1, okay, P1, which belongs to a cluster 1, okay, and you measure the distance of other from the cluster 2. So cluster 2 will be the another point. So suppose that it is P3, then your P1, P4, okay, One point is
Okay.
from cluster 1 and another. Okay. Then like that, P2 to P3 and P2 to P4. Whatever the minimum distance between the cluster is there, okay, that will be regarded as the, okay, uh, uh, that will be regarded as the distance between the two clusters. Okay. Okay. Minimum. You understand the minimum of the cluster. So suppose that this was the cluster 1, this was the cluster 2. Now suppose there is a cluster 3. Okay. 0.5, 0.6 is there. And now I measure the distance. So the minimum distance between any two cluster, whatever the minimum of C1 and C2 cluster, minimum of suppose C1 to C3 cluster, minimum of suppose C2 to the C3 cluster. Whichever has the minimum of distance, whatever the minimum distance, like P2 to P3 is the minimum distance, it appears here. Okay. Or
Yeah.
suppose that whatever it is. Okay. So that I will be combining as a cluster, as a hierarchy will combine that cluster. Okay. Combine it that. So because when I merge any cluster, I take the minimum distance between the clusters, right? But the minimum distance, but the distance I will be measuring from the minimum points. Okay, the minimum points. You got it, right? The minimum points
Yeah.
from the cluster. So this point to this point, I will be considering as a D1 distance. And from this to this, I will be considering the D2 distance. Suppose these are the minimum distance between that. So whichever is the lesser, it will combine with that. Okay, that is called as single linkage or the minimum linkage. Got it?
Yes.
You got it,
So
right?
yeah, yeah. So from P1, P2 and P3, P4, P2 and P3 are minimum distance. That is why we are creating this this
No, no. See, I am measuring the distance between cluster 1 and cluster 2, cluster 1 and cluster 3, cluster 2 and cluster 3 distance. Okay. And whatever the minimum distance between two clusters are there. So minimum of distance between cluster 1 and cluster 2, whatever it is there, I find it out. Suppose that it is 1. Okay. C1 and C3 is suppose 1.5. And C2 to C3, suppose it is uh, suppose that it is 2. So which is the minimum distance? 1 is the minimum distance. So I will merge this. Got it?
okay,
I will measure
okay,
all the distance from all the points within the cluster. Got it?
okay. Yeah,
You are getting it, right?
yes, yes, yes. All
Okay.
the clusters will measure first, then we'll merge.
I will measure from point to point between different clusters. I will pick out the minimum distance between the cluster. Minimum distance between the cluster. The points of the cluster, whatever the minimum distance between the points of the cluster is there, between the cluster, I will be considering that as the final distance between the cluster. Okay. Got
Okay.
it?
Yeah,
Ah, here there was in our consideration three clusters are there. We are measuring from all the things. Whichever the minimum distance it is there, I will be again merging it. Okay. So this is called as a single linkage. Okay. Or a minimum linkage. Okay.
okay,
Now there is a maximum. Okay. So in the maximum, what happens? Same thing will be happening. Only the point is that I will be considering the maximum distance. Okay. As a distance between the two clusters. So this distance. Okay, from P1 to P4, whatever the distance is that, that will be considered as a distance between two clusters. Okay. Whichever
okay,
this distance is the minimum, suppose this was the D1 distance for the cluster C1 and C2, and there is a C3 cluster. Okay. So whatever the maximum point of the two cluster is that I measured it. Okay. This and this also I measured it. So if you see that this is the maximum point, suppose whichever the maximum distance between the cluster, in that whatever the minimum distance is that, okay, whichever the
mhm,
maximum distance between the two cluster is that, that will be considered as a distance, and out of all distance, whichever is the minimum distance, that will be merged.
okay.
Technique is same. Merging will happen based on the minimum distance. Okay.
Minimum distance.
But
But we'll
the
calculate what the
identification of the
maximum distance.
distance will be done based on the maximum between the
Okay.
cluster. Got it? That is called as a complete or the maximum distance. This is the complete or the max linkage method. Okay. Now third
What
is
are the
the
use cases?
huh?
what are the use cases of these individuals?
I will tell you. I will tell you. So
Okay.
first understand this point. Okay, this plays very important role. This is the part of our advanced part. Okay, which is not taught.
Okay.
Okay, which is not taught. Okay, uh, I will be telling you that what is the advantage or disadvantage of this. Okay, which one should be used. Well, at least from the theoretical point of view, we will understand it. Okay, some of the time
Okay.
it will be difficult. It is the part of advanced part. Okay, that will be exclusive by me. I will be
Ah,
telling. Okay. So now third point is the average. Average is that calculate all the distance between the. Okay. Let me how to remove this. One second, just hold on. Okay. Okay. So in the average case, what will happen? We will measure all the distance. Okay. Like whatever we measured it, right? P1, P3, P1, P4. Okay.
okay.
P2, P3. Okay. P2, P4. We measure all the distance. We will take the average of that. All the distances divided by 4. Okay, whatever the average distance is that, and minimum of the average distance will be the factor by which we will be combining. Got it?
Okay.
Simple?
Yeah.
Okay. Now, centroid method is that sum all the points, okay, divided by, if suppose that whatever the n is the total number of points in one cluster, divided by that. Okay, that will be the central value. Okay, that will be the central value. That will be the centroid. Suppose that you have a point which has uh, um, the suppose it is a one dimensional point. 5, 4, 3 are the values. Sum it up, divide by 3. Okay, so 9 plus
Okay.
12 plus 3, 4, 4. So that will be the centroid. From centroid to centroid, you will, like in this case, suppose this is the central value and this is the central value. Okay. You will measure the distance between the centroids from all the clusters, and whichever has the minimum distance, you will be merging it. Done.
Okay.
This was the thing which I was telling, that which we have used in the while we were understanding the hierarchical. Okay. Now
Yeah.
there is a Watts method. Okay, Watts method. Watts method is actually your it takes the variance into the account. Okay, variance into the account, sum of a square. Okay, so what it happens, it decides that suppose let me do this. I can do this, right? Okay, let me do. So here, suppose this was the one cluster. Okay,
Okay.
three clusters are there. Suppose intermediary cluster. Okay, it is not the cluster form. So these are the points are there. Okay.
Okay.
So what will happen here? C1 will try to combine with C2. C1 and C2 combine. Okay, it will try to combine C1, C2, and C1 and C3 combine. Okay, C2 and C3 combine. Okay, it
Okay.
combines. Suppose that it is calculation is happening. Suppose if I combine with C1 with C2, C1 with C3, C2 with C3. Okay. It measures the internal variance, sum of a square. Okay. Sum of a square. We have seen the inertia in K-means. Remember that, right?
Yeah.
Inertia. So same thing here we will be doing it. Okay. So we will be measuring the sum of a square. So from the centroid, whatever your centroid is, that suppose centroid is from C1 centroid minus all the data points, okay, square. Okay, this is the sum of square. I is equal to 1 to n. Okay, this formula can be uh, slightly different also, like it is also the your distance of the centroid also, it can be divided by, okay. So it can be also that formula, or this is the formula. So suppose this is the formula, sum of square, okay, right now.
Okay.
Similarly, we will check for the, okay, it was C1. So suppose that whatever the C1, C2 collective centroid comes, okay, centroids, based on that, we are calculating the sum of square. Suppose this was merged, right? So this is the centroid. Based on that, I will be calculating the sum of square of all the values, okay. Suppose that it came as a 10. Suppose here also sum of square we calculated, it came as 11. And here it came as a 15. So whichever has the minimum sum of square, okay, the variance, okay, which has the lower variance, okay, that will be considered as the combination point, okay. Lower the variance, we will be combining. And as I told you, the philosophy of your cluster is that within the cluster, within the cluster, it should be similar. It means that variation within the cluster should be lesser variance, okay. Across the cluster, okay, there should be difference, okay, it should be dissimilar, okay. So so it is trying that whichever cluster I am merging it should be more similar. It means it should be closer, okay, it should be closer, okay. And it is identified by the variance part, okay, variance part. Lesser the variance, okay, lesser the variance, it is
Okay.
showing lesser variability, combine it, okay. So we do this,
Hmm.
whichever has the lesser variance, it combines with that, okay. That is the Watts method, okay, Watts method. By default, in the sklearn, whatever the your function is there, that's use the Watts method, because it is statistical methodology to deal with, okay, statistical methodology to deal with, okay. Generally it is by default it happens, okay. So this is the one point about the hierarchical clustering, okay, that this clustering has a hierarchical in approach, okay. In hierarchical clustering, we discuss 2 points: agglomerative part and the divisive part. I will tell you divisive part, okay.
Okay.
Divisive part, it is not used, so we will take it uh, only at the very high level, okay. Divisive is that in the agglomerative we consider all the points as a cluster, okay. We
Okay.
consider all points as a cluster, but divisive clustering, we consider all points as a single cluster, large cluster. Then what will
But
happen? We will divide this into, suppose, this to this cluster, okay. We will divide on certain basis, then divide it like that. We do the divisive part, okay. We keep dividing from one cluster, we try to break it. Now if you understand that from the scalability point of view, how I should divide it, it will be slightly difficult, okay. So I have not
hmm.
seen any use cases that which uses the divisive methodology, okay, divisive methodology, but it is a part of the hierarchical. First of all, hierarchical clustering has a problem that it is too much computationally extensive,
Okay.
computationally highly expensive, okay. And divisive also, it is not a scalable methodology, okay. It is
Okay.
even slower than the your agglomerative part, that which we have seen it. So this is the technique which we have seen from the hierarchical point of view. Now, the next step is that we will see that how linkage method impacts your cluster part. Okay, this is number 1 point. Okay, number 2 point which we are going to see in the next video. Okay, is about your um, one is a linkage part, the complexity, computational complexity, okay, the complexity, how much it has a complexity in terms of time and the space, okay, how
Okay.
much it is there. Then we will see that what is the benefit of hierarchical Fourth point is that comparison between your k-means and hierarchical. Okay, this we will be seeing it. Okay.
Okay.
Any question?
No.
Okay. So I'll close this. Okay.
Okay.